Hello, Pasco School District Algebra students. My name is Mr. Montes. I am a Pasco High School Algebra teacher. If I sound familiar, that is because I recorded the last video lesson, which was not last week, because last week was quote-unquote spring break, but the week before that. So we have two things for you guys this week. We have this thing called comparing lines. There's two parts to this. The first part is called the race. It's page 1 and page 2. I will actually be walking you through these first two pages in this video lesson. And then the second part, the walkathon, is also 2 pages. And this one is left for you as an assignment. We have another piece as well, just like we did last time. It's called staying sharp, or that's what we're calling it. And this is just some skills and some procedural things that we would like you all to keep up on. These are things that you've already learned. We have some systems of equations this week, systems of inequalities, some solving equations, as well as some simplifying some expressions. And as always, with staying sharp, we like to include the responses that you should, the answers that you should get. If this is not something that you're coming up with, or if you're confused, remember you can always contact your teachers to get some guidance and help from them. Okay. So let's jump right into this, because I only get 15 minutes of recording time here with this free software, and I ran out of time last time, so this is my second time through. All right, so let's go to OneNote. It'll be easiest for me. It's called The Race. It says Maggie and Emma race each other along a straight running track. Maggie starts some distance ahead of Emma. The graph describes the race. All right, so they haven't actually asked us a question here. We're just given a description of what's going on. So we have Emma. It looks like we have time in seconds along the x-axis of the graph. Along the y-axis, we have distance from the starting place in yards. I can tell that they're going to end at 70 yards because that's where the graph ends. It stops here and here, so they're racing to get to 70 yards. And it looks like Maggie got a little bit of a head start because she is 30 yards away from the finish line. She is 30 yards away from the starting point, so she got a 30-yard head start over Emma. So let's go to the first question. The first question says, after 5 seconds, who is running the fastest? Explain your answer. So there's a couple of different ways that you can look at this. What I'm going to do is I'm going to go ahead and calculate Emma's rate of change. So we're looking at 5 seconds. And the rate of change should tell me how fast Emma's going, and I should be able to compare it to Maggie's rate of change, which we're going to calculate second. So if we start here at the starting line, after 5 seconds, 2, 3, 4, 5, Emma is right here. So when we talk about rate of change, we're actually talking about this thing called change in y over change in x, which a lot of times people interpret as your rise over your run. Now in this case, my rise is how far I go up, and I went up 25 yards, so not me personally, but Emma. So Emma, she ran 25 yards, and now we got to think about how long it took her to run those 25 yards. So I'm going to go across here, and it's 5 seconds. So for Emma, 25 divided by 5, I got 5 yards per 1 second. So what does that rate mean? Well, if we read it out loud, it says 5 yards per 1 second. So that means that Emma, every 1 second, runs 5 yards closer to the finish line. All right, so that's just Emma. But if we really want to see who's running fastest, in terms of numbers, we need to calculate Maggie's as well. So we're going to do the same thing, except Maggie does not start, change in y over change in x. She does not start at 0. She starts 30 feet away from the starting line. And we're going to look at it for 5 seconds as well. And I'm going to look at her rise, which in this case is from 30 to 40. That's only 10 yards. And then the run is 5 seconds. 5 seconds. Okay, so this reduces down to 2 yards per 1 second. So Maggie, in 1 second, can travel 2 yards. So if we look at this after 5 seconds, who is running the fastest? Explain your answer. Well, let's take a look at the rates. Emma is running at 5 yards per second. Comparatively to Maggie, she's running at 2 yards per second. So Emma's running faster. Now here's the tricky thing. It says after 5 seconds. But from what we know of linear equations is that the rates don't change. The rate actually is the same no matter where I calculate it at. So this part's a little bit tricky, a little bit misleading, because it doesn't matter if it's after 5 seconds, after 2 seconds, after 14 seconds, because Emma's always going to be running faster than Maggie. And we can tell based off the rate of change that we calculated, but we can also tell based off the slopes of these two lines. If we look at the steepness of this blue line, which is Emma's, it's steeper than Maggie's. The reason for that is because Emma's traveling faster than Maggie is. All right, so let's go on to the next part. It says Emma's line can be represented by the equation S equals 5t. Okay, S is the distance in yards from the starting place. T is the time in seconds from the start of the race. What is the equation that represents Maggie's line? Well, let's take a look at this thing. I'm sure you've seen it. B represents the y-intercept, and M represents the slope, or the rate of change. So if we look at Emma's line, we have S equals 5t. 5 is my rate of change, which we got from, they get from there, 5 yards per second. However, she doesn't have a y-intercept. Well, it doesn't look like it. Plus 0. And anything plus 0 is just 5t plus 0 is just 5t. That's why they left it as 5t. So we can actually use that to calculate, or to give us information on how to calculate Maggie's line. So y equals mx plus b. So this will be not y but s equals. Now Maggie's rate was 2 yards per second. So I'm going to write 2 times t. Now the y-intercept, let's take a look up here. It's 30. So plus 30. So that'll be my equation for Maggie's line. Now over here I said y equals mx plus b. And instead of y I used s. Instead of x I used t. Well, that's because that was given to me here in the instructions. So it says describe what happens in the race. Okay. Let's real quickly go over that. It looks like Emma and Maggie are racing. We already knew that. Maggie got a head start. In fact, a 30-yard head start. They both start at the same time because their graphs both start at 0. And Maggie is running a lot slower than Emma is, and we can tell by the rate of change as well as the steepness of the graph. At 10 seconds, Emma and Maggie are exactly the same distance away from the starting line. They're both 50 yards. However, after 10 seconds, Emma overtakes Maggie and ends up finishing after 14 seconds, whereas Maggie finishes after 20 seconds. So, all in all, Emma beats Maggie. Let's go to the second part. So we have here, it says the diagram below shows the distance a runner is from the starting place and from the finishing line. So we have this little graphic right here. The following equation can also be used to describe Emma's race. F equals negative 5t plus 70. F is the distance in yards from the finishing line. Last time we were looking at it from the starting line. And t is the time in seconds from the beginning of the race. That one still stays the same. Part A, plot this line on the graph. Well, that's easy. Remember last time I just told you y equals mx plus b. Well, this is our y-intercept. And this is our slope. Now notice that this number, negative 5t, looks very similar to what Emma's rate was before. It was 5. Well, because we're talking about in terms of distance from a finishing line, and she's going at 5 yards per second, this time it's negative because we're gaining on that finishing line. I hope I explained that well. I might have gotten a little tongue twisted. But anyways, so we're going to plot this line. We're doing it in blue because it's Emma. So I have here, she starts at 70. and her slope is -5 over 1, but I'm actually going to think of it as -10 over 2. And that's based off of the scaling that I see here. If you can hear that, that's my daughter in the background. Just ignore her. So down 10 over 2, down 10 over 2, down 10 over 2, over and over. Down 10 over 2 and down 10 over 2. And she finishes at 14 seconds. So let's see, I'm going to draw in my line. It won't be perfect, but it'll be close. All right, so that represents Emma's line. Now the next thing they're going to do is ask us to add a line that represents Maggie's race. Now if you remember, Maggie got a 30-yard head start. However, because we're thinking in terms of distance from the finishing line, Maggie wasn't 30 yards from the finish line. She was actually from 30 all the way to 70. She was 40 yards from the finish line. So Maggie is actually going to start here because she's 40 yards from the finish line. Now Maggie's rate of change was 2 yards per second. So we're going to think of that as -2 over 1. But I'm actually going to change that into -10 over 5. These two fractions are equivalent. It's just I'm going to use this one because if I look at my scale, it's going to allow me to plot this a little bit easier. Because when I go down 10 yards, when I'm 10 yards closer, I'm going to go over 5 seconds. 10 yards closer, over 5 seconds. 10 yards closer, 5 seconds. 10 yards closer, in 5 seconds. Now if I do this, I'll be able to draw in Maggie's line. There we go. And just like last time, I mean, this is still saying the same story. Emma starts 70 yards away from the finish line. Maggie starts 40 yards away from the finish line. Emma's traveling faster. Her line is steeper than Maggie's. After 10 seconds, they're both 20 yards from the finish line, but they're 50 yards from the starting line. And after 10 seconds, Emma overtakes Maggie, finishes after 14 seconds after starting, whereas Maggie finishes 20 seconds after starting. So, almost done here. The next part says, what is the equation of this second line? Well, again, y equals mx plus b, except instead of y, we are going to use f. That's what they told us up here. And instead of x, we are going to use t. So I'm going to write f equals, my slope for Maggie is going to be -2. And then there's t. And then it's going to be plus where we started, and she was 40 yards from the finish line, plus 40. Let me change this black F. And there you go. Now, it's really hard to do lessons online because I can't gauge if you all understand this or not. But feel free to pause and rewind and go back and take a look at some of the stuff that I said. And again, if something is confusing, feel free to email your teacher or another algebra teacher that you trust at the high school. And I'm sure they'll be more than willing to get in contact with you. But your assignment is going to be, we did the race together. It'll be just the walkathon, which is page 1 and 2. After you get it done, if you would like some feedback on it, go ahead and send it to one of your teachers and they can give you some feedback. But as far as this, we're all done. Hope you guys have a good week and we'll talk to you soon.